Hello, in this section I'm going to show you how to work further applications of right triangles. So these kinds of questions, they usually deal with this idea of looking at a bearing. So whenever we look at a bearing, we're talking about like, for example, if I have a ray of which I have an indication of north, and then I have something of this nature where we might say that this bearing goes in this direction, which we might indicate, for example, that this is a 30 degrees bearing, or for example, if we have another, uh, let's actually make this, well, this is actually good enough actually. So like, say for example, we have a bearing of 90 degrees. So in this case, you'd have something like that, and then you would say that that's a bearing of 90 degrees and that this is going to be north. Now, in any case, you do have that there's, just some more examples of like how you can view a bearing. So again, usually you have like a straight line that points up north, and then let's say that you have a bearing that kind of goes something like this. So in this case, well, this would be, maybe we could say, for example, that this is 220 degrees bearing. Okay. Now, similarly, we can also have where you have that the direction is still indicated as north, but you have something like this, where you might have that the bearing is like, say for example, like 300 degrees. So in that case you might have something that goes around like that. Well, not exactly like this, but let's just go ahead and write it like that. So we have that that's 300 degrees perhaps. Now, other ways of which that you can look at this idea of bearings is that, say for example, that we were to say the term north, like north 42 degrees. Um, so like, we'll just say that this is an alternate. We'll just say that this is an alternate method. So for example, let's say that we have something like this, and we still indicate the direction, but we go ahead and we say like north 42 degrees with east. So this is kind of like northeast. So in this case, we have that the bearing, it's still in the same direction relative to the north, but in this case, we're indicating 42 degrees northeast, whereas like we might say, bearing 30 degrees and so on. So this is kind of like an alternate way that you can kind of look at this. So similarly, if I was to draw um, something like this and then like that, but then let's say that we have that the direction of our angle goes like that, and we indicate that this is going to be south by 40 degrees. In this case, you're pointing to the west, so you have that that would have to be west. And we'll say that this right here, um, right, so this right here is going to be the 40 degrees in this case, but by southwest. But let's go ahead and indicate the direction, so south. So it's relative to the south in this case that you have that that's 40 degrees. And then similarly, if you have something like this, and then you have like that, and then you have south, but let's say that, for example, that the angle measure, it forms like that. Well, in that case, you can still indicate the angle measure. So like, let's say that that's 30 degrees. But to be more specific, you would say the term south 31 degrees, and in this case, it would be east. So you're getting this notion of northeast, southeast, southwest, and then we'll have a similar way that we can actually show northwest. So, like let's say that you have an angle like that, and that's the north, and you have that the angle is in this direction. So we can say that it has a bearing of 52 degrees by west. So you have 52 degrees by way of west. And of course, yeah, you can type in or just write down that that's 52 degrees because relative to the north, but pointing in the west, you have that it's 52 degrees. Now, let's say that, for example, that we try to work a problem. Now, if we try to work a problem, then in that case, we just have to kind of know what the question's asking and the way of which that we can kind of put it all together. So this question says that two docks are located on a east to west line, and I'll just put it up here, east to west line 2,587 feet apart. From dock A, the bearing of a coral reef is 58 degrees 22 minutes. From dock B, the bearing of the coral reef is 328 degrees and 22 minutes. Find the distance from A to the coral reef. Okay, so let's put this together in a way that kind of makes sense. So let's say that we draw a triangle. Okay, so we'll draw a triangle, but from here we're going to draw this like that. Okay, now I'm going to label this as A, and this is going to be B, and then this is going to be C. Now, in this case, we just have to say that, for example, that we have the bearing, so we just have to indicate our north by our north. Yeah, we'll just have to indicate the direction of north as follows. So this is the north, but we know that the bearing, it's 58 degrees and 22 minutes. So in that case, that would imply that we can find this angle measure right here. Now, in that case, that means that you would have to figure out what that angle measure is by taking 90 minus 58 degrees and 22 minutes. So we could probably say that A is equal to 90 degrees minus 58 degrees and 22 minutes. And this is going to be 89 degrees and 60 minutes. So that's going to be minus 58 degrees and 22 minutes, which this equals to 31 degrees and 38 minutes. So what that means is that we're just going to write down that this angle is 31 degrees and 38 minutes. Okay, now keep in mind that this right here is a right angle, and we have that the point of which that we had to refer to as the bearing to it's like relative to the coral reef. So in this case, this is the coral reef. So if you want to label things appropriately, you can. So let's say that we know that this is 2,587 feet. Okay. Now, the question also states something about that the bearing of from the coral reef to dock B is 328 degrees and 22 minutes. Now, interestingly enough, basically we're going to do something like this, where we go ahead and we say, well, if that's going to be the case, then we're going to have something like this. Okay, so that's the 328 degrees and 22 minutes bearing. Now this is actually kind of neat because if you kind of imagined for a second that, let's say that you zoomed in on this, you could actually draw a north line, and then you could say, well, I know that from that north line right here, respectively, you have that's 270 degrees that we have so far. That means that from there, that 58 degrees and 22 minutes would be right here too. So in that case, it's kind of like we're using, or it is like we are using geometry. So in that case, that would imply that the angle measure that you have right here, it's actually also um, 58 degrees and 22 minutes. So let's just put that right there. So that's 58 degrees and 22 minutes. And the way that I got that was I just took 328 degrees and 22 minutes and I subtracted 270 because I could see that, you know, from here to here that's 270. So the remainder is the 58. So that gives me 58 degrees and 22 minutes. Now, the question that is being asked is actually the distance from A to B. So that means that we have that this is going to be B. Now in that case, what we can do easily is say, well, since I know the angle measure right here, and I know this part right here, and I know that that's the unknown, we can actually just put this together. So consider this. If we were to either do a projection, like if we were to draw the triangle again, perhaps, and like for instance, we have that the hypotenuse is the 2,587. The the adjacent is the B. The angle is 31 degrees and 38 minutes. So in that case, that means that we can actually solve for this distance. In this sense, we have that, you know, it's not really important in terms of like what we'll have right here necessarily. So we can actually put this together very nicely. So the next step would be that we would just say, well, relative to 31 degrees and 38 minutes is the adjacent, the unknown, and the hypotenuse. So that's going to be cosine of 31 degrees and 38 minutes is equal to B divided by 2,587. Now, when we multiply that through, you're going to get that B symbolically is equal to 2,587 multiplied by cosine of 31 degrees and 38 minutes. Now keep in mind that you didn't have to do it like this, but you know, it seems like it's the most convenient. So the next thing that you would want to do is you want to get your calculator and take 2,587 multiplied by cosine of 31 degrees, and I'm going to just do the conversion. Let me see, 31 degrees and 38 minutes. So that's going to be 38 divided by 60. So let's just do that. And it looks like if we round to the nearest mile, then in that, or foot, sorry, If we round to the nearest foot, we find that that's going to be 2,000 2,203 feet. So that's the answer. And that's just by using some bit of trigonometry and using what we just learned as it relates to the bearings. Okay. Now, I could have put all of this together with respect to, like, what if I just found this angle? But this angle always ends up being 90 degrees in any case. You may find other examples where perhaps the angle might be different, but in that case, it's going to require things beyond the the context of where we're at right now. So you might end up looking at examples where you have that you would need other methods like law of sines or law of cosines, and right now that's just not where we're at. So yeah, you have to um, kind of have to limit yourself to just working with right triangles for now. So the other thing of which that we can actually look at, for example, is a problem where it's going to involve quite a bit of information in this case. So like, for example, if I have a triangle, so I have this triangle and it has to have a right angle. So let's just do this again. Yeah. Okay, so let's just draw a triangle. Okay, that's good enough. So let's say that in this triangle there's a second one that's inscribed. So in this case, I'm just going to draw something like this. And what I want is I want to find, in this case, the height. Okay. Now, we'll go ahead and we'll write down a few things. For example, like we'll write down that this right here is 168 meters. Now, in this case, the angle measures are going to be as follows. You have that that's 52.5 degrees, and then you have that this right here is actually the angle that's inside. Yeah, this is going to be 52.5 degrees, and this angle of elevation, that's going to be 41.2 degrees, and we'll just indicate it like this. Okay. Now, to do this question, we actually have to model it in a way that we can find the height. Now, it looks like we can use some advanced methods, but I don't want to do that. So let me just put an X right there. That way you kind of have an idea where I'm going with this. So to do this question, we have to basically say we have one right triangle, and then we have another, a smaller one. So for example, tangent of 52.5 degrees is equal to h over x. But that implies that you have x is equal to tangent. X is equal to tangent. Yeah, x is equal to, or not x, but tangent. So h. So x times tangent of 52.5 degrees, and that's multiplied by, or that's equal to h, right? Okay, now in this case, the other thing of which that I can do is I can actually say, for example, that tangent of 41.2 degrees is equal to, well, look at this, h over x plus 168. Why is that? That's because like this is opposite to that angle and the adjacent is x plus 168. Now this is where things get a little complicated because now I have that if I go ahead and I say x plus 168 multiplied by tangent of 41.2 degrees is equal to h. So now it's like I have an expression. I have an expression that deals with both h in terms of x. Now this is not necessarily a problem, but it does get a little bit messy. So for example, we can say that we have x plus 168 multiplied by tangent of 41.2 degrees is equal to, well, in this case, x tangent of 52.5 degrees. Now this is where it gets a little interesting because I need to basically solve for x now. So the next step would be to get x tangent 41.2 degrees plus 168 tangent of 41.2 degrees is equal to, same thing, x tangent of 52.5 degrees. Now the next step is that we need to basically get everything on one side. So let's go ahead and just say that we'll just subtract the x tangent of 41.2 degrees. Now, if you already, say for example, want to plug this into your calculator, you can technically, but it's probably just better to work this out. So you have x tangent 52.5 degrees minus x tangent of 41.2 degrees equals to 168 tangent of 41.2 degrees. Now, the next step is that you basically identify that there's a common factor. That common factor is x. So what ends up leading is that you end up with x multiplied by tangent of 52.5 degrees minus tangent of 41.2 degrees is equal to 168 tangent of 41.2 degrees. Now, it looks like basically if you divide, you end up with whatever x is equal to. So x is equal to 168 tangent of 41.2 degrees, but all of this is divided by the difference of the two. So you have 52.5 minus tangent of 41.2 degrees. Now, this is where you have no choice but to go ahead and plug it into your calculator. So if you do this, this is only going to tell you what x is equal to. Then from there, you're going to multiply that by tangent of the other angle measure, but we'll get there. So let's do, I think it's like this. So 168 times tangent of 41.2, and then you have the difference of the two. So tangent of, let's see, 52.5. And then you just close it. Now the nice thing about doing it like this is that, oh, we forgot 0.5. The nice thing about doing it like this is that there's no need for an enormous amount of parentheses because we put the fractional expression. But if you do end up doing it that way, then just be sure that you put enough parentheses as needed. So looks like that's it. Let me see. 41.2. Okay, so we hit enter. And we get that this is 343, well, 344. But notice that that's not the answer. So, so like, let's say that we do this, let me see. We do this in a way that, yeah, we go ahead and we say 343.80 meters. But remember that h is actually equal to that answer, x multiplied by tangent. So we're going to just go ahead and take this answer and multiply by tangent of 52.5, because remember, x times tangent of 52.5 is the actual answer. So that gives us 448. Okay, so we have that that's going to be 448 meters. So this is actually the answer. And notice that if you would have taken 343.80, you would have probably gotten close. Let's see, multiplied by tangent of 52.5. Let's see. Yeah, it's not too bad. It's just off by a little bit. And I mean, if you're going to round to the nearest meter, because if you go back and you look at the significant digits, you have that it's basically uh, that, yeah, you have that there's 3. So that means that we're rounding to the nearest meter in this case. So the answer actually is 343 degrees, and this is where I found that answer. So, if you want to put it all together, for example, like really all together, you could have said that h symbolically was equal to 168 tangent of 41.2 degrees, um, and then tangent of 52.5 degrees, and then all of this is divided by the difference of the two. So you have tangent of 52.5 degrees, and then this is going to be minus tangent of 41.2 degrees, and then you just put that all together. So it gives you basically the same thing, like 448 meters. Now, sometimes it is true that sometimes that you can basically kind of form patterns, like where you're able to look back at the original diagram and say that, you already know what the answer is just by looking at it. Um, you know, that is one way to look at it, but hopefully you kind of approach it in a way that you can say, well, if I already know that I can use the definition of tangent, and then from there the rest is algebra, then why do I need to go through a process of memorizing a formula? That's just me, okay? So in this case, like, I prefer that I just solve it algebraically, if anything.